really be using for your VXLAN networks. We'll then move on to looking at some of the greenfield and then the brownfield provisioning options with DCNM. We then go on to DCNM Day 2 operations and some short demos and conclude with installation and licensing. So that's the agenda for today. Now without further delay, let's get started with introducing DCNM. Now, Data Center Network Manager is a single management solution for various kinds of fabrics and topologies and architectures in data center. One of the most favorite and famous kind of network that you can bring up with DCNM and manage with DCNM is a VXLAN EVPN based fabrics. We can also use DCNM as a controller for classic LAN, for IP fabrics for media, also called as the professional media networks, and storage area networks for MDS and Nexus. So those are the pillars for DCNM. Those are the different modes in which you can use DCNM. Now DCNM can be accessed via a GUI, whereas we also have REST APIs to interact with the solution. This can be used for provisioning not just a single site but multi-site and DCI and external connectivity as well. And one of the most important aspects, I think, when it comes to a controller-based approach is the ability to be able to back up and restore from a particular working state. So we have that covered in DCNM, and we'll be talking about all of these in the further sections. Now, we have a lot of provisioning options, but when it comes to day 2 operations with respect to maintaining and getting the visibility and troubleshooting tools with DCNM, there's a lot that we have. Now, we have a lot of provisioning options, but when it comes to day 2 operations with respect to but of your compute as well. We have a lot of performance monitoring, fault management, your events, alarms, and audit logs, accounting logs all captured. Another important aspect of DCNM is configuration compliance, which essentially keeps track of the intent that the user has pushed from DCNM and makes sure that the fabric and the respective switches in the fabrics are always complying with this intent. Now, the module that's responsible for keeping that in check is the configuration compliance piece. Image management, upgrades, RMA of a particular switch. Again, we have all the workflows in DCNM. And last but not the least, there is network insights, which we'll be briefly touching upon in this session today. Now, when it comes to DCNM modes and how can we actually map DCNM modes with the architecture deployment models, there are two buckets in which I'd like to put these models under. One is a fabric or overlay model with VXLAN and BGP EVPN. This is a leaf spine architecture with VXLAN in the data plane and BGP EVPN in the control plane. Whereas then we have the traditional model, which can be either a 2-tier or a 3-tier architecture running spanning tree, VPC, fabric path, OTV, and pretty much anything except for VXLAN. Now, those are the two big buckets when we're talking about deployments or architectures in the data center world, again on the LAN side of the house. Now, this session is, of course, going to focus on the LAN part of the data center. Now, this session will be covering the LAN fabric mode, that's the installation mode. And for VXLAN fabrics, we have something called as the Easy Fabric template, which can be used for a Nexus 2K, 3K, and 9K. So it's important to remember LAN fabric mode, that's the installation mode, and that's the template called the Easy Fabric template that should be used for VXLAN BGP EVPN fabrics. For everything else and for any other kind of Nexus platforms ranging from the Nexus 2K to the 9K, we have two different kinds of install modes. One is again the same LAN fabric mode, which is the installation mode. And this time, if you see the template is different, it's called the external fabric template. And then there is another installation mode called as a LAN classic mode. And since we have two of them, I'm going to compare and contrast between the two and recommend which one you should be using for your Nexus 2K to 9K. So that is how we map the deployment models with the DCNM modes.
Look at this Excel sheet.
So beautiful. So elegant.
Just looking like a wow. You will be surprised to know that I made this entire spreadsheet even without writing a single line of Excel formula.
Now, since we spoke a lot about LAN fabric mode, let's talk about what it really is and what it brings to the table. Now, LAN fabric mode was a completely different architecture introduced with DCNM 11, which shipped in, I believe, June of 2018. So it's been shipping for quite a while now. And it has a lot of great feedback from our customers. We've heard really good things about LAN fabric mode. Now, there are 4 steps that makes it easy to use a LAN fabric mode. One is where we define our intent, and your definition is basically based on templates. You're using out-of-box templates, or you can also customize your templates where you have your intent defined for your underlay, overlay, as well as interfaces. Now, once you're ready, you would click on Save, which basically instructs DCNM to start generating the configurations which are needed for the switches to do what you just asked it to do in step number 1. Once it generates the complete configuration, you have full preview with a side-by-side diff between the generated config and what's running on the switch, which is the running config. Now, once you preview and if things look okay, then you go ahead and you deploy your changes. And that really, step 1, 2, 3, 4, right? That's how you actually use the LAN fabric mode, and pretty much any changes that you'd push would involve these modes. And basically, your fabric is ready in just a few minutes. Now, if you remember, we spoke about 2 different install modes called the classic LAN, and then we talked about the LAN fabric mode with external fabric template for a traditional model. Now, if I were to tell you which one to use, this slide is basically my recommendation on which way you should be going. Whether you're using VXLAN or you have a classical LAN deployment with VPCs or maybe Fabric Path or OTV with an XS7K, my recommendation is to use the external fabric templates with the LAN fabric mode. And why do I say that? One of the biggest advantages of using the external fabric template is the fact that it's embedded within the LAN fabric mode. Now, what that means is you can actually use VXLAN, you can use your easy fabric templates, or you could be, using a lot of features that we have invested on in the LAN fabric mode because it's part of the same install mode. Classic LAN, on the other hand, is a primitive way of doing things. It's the old way, so definitely, not recommended. And as a team, we are investing on the LAN fabric mode. So external fabric template being part of the LAN fabric mode gives us big benefits. Now we have a lot of features here in addition. We have configuration compliance. We have backup and restore of not just the config, but also the state when we're talking about external fabrics. Our templates are based on a different architecture. We're using Python this time for building all our templates, which we all know is a lot more flexible compared to just CLI based model. We have endpoint locator, which is to locate our endpoints in the fabric and track moves over a long period of time. One-click VPC pairing options and bootstrapping, patching, and POAP available for our switches. So as you can see, either it is equivalent to LAN classic mode, or a lot of features. There are additional benefits that we get with external fabric. So definitely my recommendation is use the LAN fabric mode, and then you use the easy fabric for your Nexus 3K, 9K, and you use the external fabric templates for anything ranging from the Nexus 2K to 9K. So that's a summary of what I just mentioned. External fabric can be managed or it could be monitored mode. You don't necessarily have to manage your platforms in DCNM. You can also use it for monitoring the fabrics and the switches. So you have an option there. And then, of course, we're supporting the Nexus 2K to 9K for VXLAN as well as traditional fabrics. And currently, we are supporting some of the non-Nexus devices as well with iOS XE, XR, and third-party devices. And you're going to see this list grow more and more as we release newer versions of DCNM. DCNM 11.3.1, that's the latest and greatest. That's available on cisco.com. So if you're installing a new fabric and using DCNM for the first time, absolutely a recommendation is to go with DCNM 11.3.1. So that was a little introduction of DCNM. Now let's look at some of the greenfield options and what are the steps that are involved when we're deploying VXLAN from scratch in our fabrics. Now before we look at the steps, let's see when you would be using this option. So if you're not on VXLAN today and you do not want to use CLIs and go to config guides and worry what are the best practices and how should you really be going about this, DCNM LAN fabric mode is for you, where you use this mode and build your VXLAN fabric in just a few minutes. Now, as I had briefly mentioned before, we have templates which are out of box, and these can be used for all the provisioning, as we will shortly see. But one of the biggest aspects of these templates is that they already embed best practices. So you never have to worry about doing anything wrong. Any option you pick is going to be the right choice. And then these templates, of course, give you options to pick your IP addresses, your overlay pools, your underlay routing protocol, and what kind of replication you want to use. It gives you the best options. You can pick and choose, and hence it makes it very easy. Few clicks and you're up and about with your underlay and overlay VXLAN deployment.
जय गो माता जय गोपाल। आप देख रहे हैं गोकुल धाम गौ सेवा महातीर्थ झज्जर हरियाणा में। ये हमारा आईसीयू वार्ड है। इस
Now we have something called as the fabric builder, which basically is used to build our fabrics, as the name suggests. And here again, I'm going to illustrate some of the steps that are involved in using the fabric builder. And now we're talking about the underlay. So step number one is where we create. Now here is where you're going to, as a user or as an administrator, tell us what is your intent. So here you're going to create your fabric. We'll pick an AS number. You'll tell us if it's ingress replication mode, for example, what kind of routing protocol you want to use, OSPF, ISIs, whether you'd like to back up your fabrics, define the schedule. So you're doing a lot of things at a fabric level in step number one. Step number two is where you're going to discover your switches. So now you have a fabric. Now step two is where you're going to add switches to that fabric. And of course we support POAP and bootstrapping options, or you can discover them in other ways, as we will see.
Once you import your switches, you will tell DCNM that these are the switch roles. This is the leaf, this is the border gateway. You can use one-click VPC pairing option to create VPCs as well. So step 1 and 2 is where you're telling DCNM what you want the switches to do, what should the fabric look like. So that's your intent. Step 3 is where you'll save your config, you preview it, and you do a deployment. And if you see, there's an orange box on 3, 4, 5. So that basically is for any changes you do here on. Step 1 and 2, of course, is a one-time change. So that is how you actually, again, in a couple clicks, you go about building your underlay using your fabric builder. So let's look at how this actually looks in the product. Now step 1 is where you will create the fabric. So that's your fabric builder, and if you're starting fresh, there won't be any fabrics. So you click on that, you give it a fabric name, and for your VXLAN, for your 3K and 9K, you will pick easy fabric template. For all other platforms, if you have your VXLAN deployment in the fabrics, you pick your external fabric template. So here is an example of an easy fabric template where you will go on and define your BGP AS number. You will tell us what kind of routing protocol you want to use, what is the gateway MAC, and as you see, a lot of things are already pre-populated, but of course you can change these things. You can pick from the replication mode, define VPC options, and resources. As you see, again, a lot of these pools are predefined, which you can change. You have your bootstrapping options. You can define an external DHCP server and a config backup schedule. So all that you're doing at a fabric level. Step 2 is where you will discover your switches. So once you create your fabric, it will show you an option to add switches. as you see here. So you're going to click on that. Now here there are two options. You can discover your existing switches using an IP address of a seed switch, your username, password, and the number of hops. And your preserve config will be a no because we're looking at green field. So if you don't want to preserve any config, you can click on no. The other option is your POAP. So you can, if you want to POAP your switches, you could do that as well. Now, if you were to use your seed switch, then DCNM would discover all switches 2 hops from the seed switch, as you have 2 hops there. And once it has discovered the switches, it will show you the entire list with the model, the version it's running, whether it's manageable or not. Now you pick and choose, and you would import respective switches into the fabric. It could be all or certain list. Once you've imported the switches, you right click, set the role, and here you see there's a range of roles, and these are all in VXLAN context. So you have these roles that you would pick, the default being the leaf. And mind you, these roles are actually going to directly correspond to the kind of configs that would be generated. So this one's really important from an intent point of view. Here we also have VPC pairing, so you can have a one-click VPC pairing between, say, your leaves, and that's literally a click over there. So step 1 and 2, one-time change. Step 3, if you see, there's a save and deploy. So you're going to click there and do a save, which tells DCNM that it needs to start computing the configurations. Once computed, you can preview the configs. These are, if you're doing it for the first time, then chances are that you're going to see a lot of configuration. And imagine doing all this by yourself. It's pretty tedious, where DCNM is doing it in a few clicks. So here you can preview. You see there is a pending config, which will be what would be pushed out, and a side-by-side comparison as well between the running and the expected config. So you can have full visibility onto what will be pushed. And if things look okay, then you can go ahead, deploy. These are parallel deployment of the configs, and once deployed, you are going to see your switches as green, which means that the switches are actually running exactly what you asked in steps 1 and 2, which means that configuration compliance looked at the intent, it looked at the running config, and they matched, which is why they're all green. So that is how greenfield deployment looks like.
Or microservices. Which one should you choose? Twitter, Netflix, and Amazon chose microservices almost a decade ago.
Now, once you have your underlay configuration all done, you move on to your interface management. And here maybe you have a host-facing interface which you would like to make an access port, or you may want to allow or disallow certain VLANs, right? So there's a lot of interface level operations that you may want to run, and this is one-stop shop for managing these interfaces. Now it would automatically pop up all the interfaces based on the fabric that you want to see. You can search by a particular interface or device, and here you are able to see and actually move the admin state to say down. So do a shut, no shut, look at what was pushed out, so entire history is maintained here. You can actually run show commands, you can preview any changes that should be pushed out, and you can also add logical interfaces like SVIs and create tunnel interfaces or configure fixes. So there's a lot of options that are available here from an interface standpoint. So once you are done with your underlay, you have your interfaces all configured. Next, we move on to overlay management. So here basically it's a top-down deployment, and you can use the DCNM GUI or REST APIs to do so. Now again here, from a DCNM standpoint, these are our VNIs, our layer 2, layer 3 VNIs, which are our networks and VRFs. So again, you're going to use your templates and create networks and VRFs, so you're defining your intent. Then you move on to selecting switches and respective interfaces where you want to deploy these networks and VRFs. Once you have that done, you can again save the config, preview, and deploy. So that again, the workflow remains pretty much the same, this time for overlay. Now we have something called as a resource manager in DCNM, which is basically keeping track of the state. So it knows exactly what VNIs, what VLANs, where have you done this, at what interface and switch. So maintaining complete state in the resource manager. And at the same time, there's full history which is maintained with respect to who deployed what and when. So you would be able to see that not just for your overlays, but for your interfaces as well as underlay configuration. So that covers our overlay management. So pretty easy so far, right? We have your underlay, interfaces, and overlay all configured, greenfield deployment using templates, and again, define intent, do a save, preview, and deploy. Now, once you have your fabrics configured, there are chances that you'd like your fabric to either talk to the external world, or you may want your fabrics to be talking to each other with layer 2, layer 3 DCI. Now, for external connectivity, what we have is workflows and respective templates for VRF Lite. And you can, of course, use these where your devices can then be Nexus devices or non-Nexus or Cisco devices, right? It depends on what your devices are in the external fabrics. So you have VRF Lite, which you can use for external connectivity. And for layer 2 and layer 3 DCI, we have multi-site, which is for VXLAN fabrics. So again, here using multi-site, we have workflows and respective policies or templates that you can use. And you would begin with creating something called as the multi-site domain, which is MSD. So it's like a fabric of fabrics. You create an MSD and you put your children fabric into an MSD, and thereon any deployment that you would do would be at an MSD level. So that makes life easier when it comes to multi-site deployments. And we've also added support for tenant routed multicast. Now with DCNM 11.3, we have introduced this feature that we call the service redirection, also called as the layer 4 to layer 7 service integration. Now what we're doing here is allowing for network orchestration of layer 4 to layer 7 service appliances that you can attach to your VXLAN EVPN based fabrics. We will allow for attachment of these service appliances, be it firewall or load balancer, and you can define a service policy to tell the system how you'd like the traffic to be redirected and visualize this in the topology. You can see how much traffic was traversing these service nodes. Now, what we're not really doing is provisioning the service appliances themselves, but all the provisioning on the VXLAN fabric side would be done by DCNM. And again, the minimum release for this is DCNM 11.3.1. Now, the kind of use cases that we're supporting with this is a firewall and load balancer, both virtual and physical, allowing for both static and dynamic peering with VPC and non-VPC attachments. So for the firewall side, we're allowing for intra and intertenant based firewalls, PBR use cases, as well as tenant edge firewall use case would be supported. And on the load balancer side, we're supporting both one-armed and two-armed with PBR use case. Now with DCNM 11.3.1, we have also introduced tying of your on-prem and public cloud data centers and automating interconnect between the two. These would be done with CSR 1Ks on both sides, and all the respective provisioning on these would be done by DCNM. We would be building an IPsec tunnel with VXLAN in the data plane, and eBGP peering that would be in the control plane. And again, all workflows templates are part of DCNM 11.3.1 to automate this interconnectivity. So that's what we were talking about in the greenfield section as to how you bring up a fabric. You have your external connectivity, DCI, if you want to connect your on-prem data center with public cloud. We're supporting Microsoft Azure, and we're working on the other cloud providers soon as well. So that's really the entire greenfield section that we wanted to talk about.
Now in the next section, we'll be covering brownfield and we will see how you can revamp your existing VXLAN fabrics with DCNM.
According to JP Morgan, the Indian IT industry is going to be massively disrupted because of the rise of tools like ChatGPT and other AI advancements. As a result, millions of
Now, before we look into the workflows, let's again ask a couple questions. Are you already using VXLAN? You have a fabric that is already built out, but you'd like a controller-based approach for any incremental provisioning that you'd want to do on your devices. If you want to use DCNM for managing incrementally or building any fresh fabrics from scratch or really normalizing everything you're doing to best practices, again, DCNM fully supports brownfield with non-disruptive import of your existing switches, your existing VXLAN deployed fabrics, and you can start managing them as if they were being managed from DCNM already. In this case, DCNM is going to learn your entire topology. It would learn the configurations, the state, the IP addresses, what protocols you're using, your IP subnets, your VNIs and VLANs, right? So it's learning everything from your deployed fabric and bringing that state, onboarding that state onto DCNM. So that's really the brownfield section. Now, let's look at day in the life of DCNM, and again, how do you go about with brownfield this time using Fabric Builder? And again, we're going to start with your underlay. So step 1 is where you will create your fabric. Same way, you're going to give your fabric settings and make sure you give the same AS number. Rest of the settings, you can create new settings, you can keep things as is, or you can, keep it matching with your existing fabric. It's very customizable and flexible at this point. Step 1 with respect to your fabrics. Step 2, you would import your devices, your switches onto the fabric. The only difference over here would be that you would, for your preserve config, if you remember, there was this knob, you would now say yes because you want DCNM to preserve the configuration. From here on, you can define switch roles, you can change roles. Again, if you remember, the roles will be corresponding to the configurations that would be pushed out. So you again want to either keep the same roles or have new roles. And again, you would do a save. Now in red, that is the change, right? So in brownfield, what we're doing is, since the switches already have the configurations, DCNM will first look at what you've done and try to normalize that to best practices. So if there's something blaringly wrong that is in the fabric, it's going to point you to that and you would be expected to correct that error. Once you do that, you can preview all the configurations for the intent you've pushed on step 1 and 2. And once the preview is okay, you would go ahead and deploy it. So that's how it works in brownfield. Again, step 3, 4, 5 would remain constant for your incremental changes. And that's how brownfield works. Now let's look at some of these workflows, right? The ones in red, let's look at how they look like in case of brownfield. So once you are creating your fabric, you're going to have your fabric defined with an AS number, give it a name. Again, you can pick from easy fabric template, for example. And here you are going to add switches. Once you add the switches, you can use your seed switch, your username, password. And the other thing that you have to remember is the preserve config of yes. Now, this needs to be yes. This is one big difference between brownfield and greenfield. Once you've imported the fabric and the switches, it's going to not have any configurations. You'll see a red pop-up on every switch that says migration mode, which means that DCNM is learning the configurations, it's learning the state, it's seeing what exists in those switches. So that's what you would see for a couple minutes, the migration mode, after you import the switches. Once the switches are imported, for any changes that you've pushed in step 1 and 2, your intent configurations are generated. You can preview them, and if things look okay, you go ahead, deploy it. Now once you deploy it, it would be all green, which means that it's based on your intent. The running config matches the expected config, and at this point you are ready to verify your fabric. You want to make sure your interfaces are per your definition. So you can go to the interface page and look at, which of your interfaces were accessed, make sure, your trunk ports are allowing the VLANs you wanted. So you can configure and verify everything from your interface page. And since this is a VXLAN fabric, you'd have overlays. You can verify that from the networks and VRFs page as well. So your existing overlays, you should see the definition over there. You'll see the name prepended with auto, which is of course again configurable. So these are the networks that existed. You would see that automatically in the network and VRF page on DCNM. And you can look at where these were deployed as well. You'd see which switch, which interface, etc. So make sure you're verifying everything. This is that step where you want to make sure that all your import happened correctly and your underlay, your interfaces, and your overlay is all built up. From here on, any steps would remain exactly the same as what we've discussed in Greenfield. You can continue to incrementally manage your fabric, your brownfield fabric from DCNM. These were some of the differences between brownfield and greenfield. So that's what was with respect to provisioning. As you can see, probably your provisioning would go faster than my session even. It's pretty slick and quick to go through your underlay, interfaces, and overlay. Now in this section, we're going to look at DCNM Day 2 operations. We will see that DCNM is not only feature rich when it comes to provisioning, but also very, very lucrative and very useful when we are talking about Day 2 operations, when we're talking visibility, troubleshooting, debugging tools, which are embedded as part of DCNM. So that's what we're going to cover in this section.
India is at a pivotal moment in its history. We're about a third of.
So here is a summary slide of some of the most useful Day 2 features that we have on DCNM. Of course, there's a lot more, but I'm just covering some of the biggest features here and something that will accommodate in this one slide. So we have a real-time network view that we'll look at in the topology. There's a lot of operations that you can run, not just at a fabric level, but at a switch and at an interface level. We have configuration compliance, and we briefly spoke about that in the beginning of the session, where basically it keeps track of the intent that is defined by DCNM. It allows you to do a backup of your fabric, and then correspondingly you can do a restore from the last working state. We have endpoint locator to locate your endpoints and give you a very historical view of your endpoint data and the relevant history with the moves. Virtual Machine Manager or VMM allows for integration with vCenter and give you that compute visibility along with the network view. DCNM 11.3 also has a preview of the Kubernetes cluster visualization that we'll look at. VXLAN OAM is used for debugging of data plane and flows within VXLAN tunnel directly from DCNM. We have the workflows for upgrading your switches, for scheduling them to patch or run an RPM on a switch or even RMA a switch out. And last but not the least, there is a suite of Network Insights applications that we call Network Insights Advisor and Network Insights Resources, which we'll briefly touch upon in this session. So that's a summary of Day 2 features, and let's delve deeper into each of these. Now, in order to get to the topology view, you can scroll to the topology tab in the UI, and here you can look at topology for a fabric or your entire data center. Now, you can have a hierarchical representation of the switches here, or you can have a custom view of your topology. This is real time because it reflects the health of the switch and the link status at real time, which means that if any of your links go down, you would see that automatically, immediately being reflected in the topology. Now it shows you the interfaces which are forming the links between the switches, and if you double click on any of these links, that will take you to this view which shows you the capacity, a 24-hour traffic pattern, and also allowing you to download any of these charts. Now these colors here, the green is representing good health, so the colors represent health score of the switch, which green of course means good health, and the health score will automatically change on an event or an alarm or anything that will affect the health of the switch. You can double click on any of these switches and that will take you to a switch dashboard, as we see here, with very detailed information of that switch, including the serial number, the model number, run show commands for the switch, look at what licenses you have for that switch, what features you're using, manage interfaces for that switch, and a lot more. So here directly from DCNM, you can get to the switch dashboard. Last but not the least, DCNM, when it imports the switches and it's reading the state and learning everything about your fabric, since it has that knowledge, it is going to allow you to do a search from here. And hence you can search for an IP, MAC, a VLAN, or a VXLAN or a VNID. You can run OEM operations from here, look for your hosts or containers, and a lot more. Right, so this is basically a very comprehensive topology view. And again, as of now, we're looking at the network. We'll shortly look at compute visibility as well. Now we looked at, in the provisioning section, we looked at how you can run operations at a fabric level. But once you have your switches imported, you can also run operations at a switch level, at a device level. So here you can right click on the switch, and as you see, there's a lot of options that we have here for that particular switch. For example, you can set roles of the switch. Of course, that's directly proportional to the kind of config that would be pushed out. You can manage interfaces for that switch, look at the history of who's pushed what when from DCNM for that switch, or look at the policies that are pushed out, or even push out a custom or an out-of-box policy directly from here for that switch. You can deploy config, you can preview any pending configs from here. So here again, a lot of options for that switch.
Now these are all the device roles which are supported from a VXLAN perspective as of DCNM 11.3. So you have your leaf spines, border spine, border gateway, gateway spine, super spine, and a lot more, right, as we see here. So here you can right click and select the role of the switch. Now you can put a switch in maintenance mode, or you can, put it in active mode after you're done with an RMA. So we'll look at this in detail, but these are the different modes of operation for that switch.
Now we also added an operational status. So for your fabric, you can click on a tabular view which will show you the switches, the links within the fabric and between fabrics. And here is an operational view which basically gives you the view of what protocols are running and the link state, which definitely helps us with debugging at a control plane level, allowing us to see if the session that you wanted to be established is established or not. And again, this is a view for all the links within the fabric as well as between the fabrics. So that is the upper view right there. Now DCNM has a lot of out-of-box templates, right? So you install DCNM, and if you navigate to the template library, it will show you all the out-of-box templates which are basically embedding best practices. So there's no need to really install or download templates from anywhere. You have templates at an interface level, at a switch level, show templates, fabric templates, policy templates, so different kind of templates for different kind of platforms. And if you click on these templates, that takes you to this Python-based template, which again, is a very flexible way of using the templates.
Now you can edit any of these, or you can create your own. Again, there's a very flexible way of using the infrastructure. Use out-of-box template, edit them, or create new templates. And all of this can be done by simply navigating to template library. Now configuration compliance, again, this module is responsible to make sure that what you have defined as a policy or what you've deployed from DCNM, your intent exactly matches what's running in the switch. Now there's an out of band change that is made. You would see that config compliance would detect your out of sync status, which is represented as red. And when you click on the pending configs, you would see what are the differences, right? What is the diff between what was your intent and what was that out of band change made? And you can bring it back to intent by simply doing a deploy.
If you actually want to accept that change that was done out of band, you would need to add that intent into DCNM, and there's different ways of doing that. You can create a custom template. You can add that config into the intent of DCNM using something that we call free-form config, which is a copy-paste literally of your show running config. Now, configuration compliance as default runs every 60 minutes, but you have an option to do a resync, which would basically do it at runtime. And we also introduced something called as a CC tracker, which basically is installed on the switch, and you would need to manually, install and run it or stop it. These workflows are again via DCNM, but it's a user-driven operation. So once you install the tracker onto the switch, that helps you with real-time tracking of these out-of-band changes and report any of these onto DCNM. So there's a lot of details around configuration compliance right here. The next one we're going to look at is network backup and restore. So for DCNM to do any backups, there's two ways. One is when you're creating your fabric, you can configure a backup schedule, and you have two options. You can pick from an hourly backup, or you can do a scheduled backup once a day, or you can do both. So you're defining when you'd like DCNM to do a backup of your fabric. Again, this is a fabric level operation. You also can do a backup, a manual backup using the backup now option, and you can tag the backups, for example, anything that you would want to call it, for example, before maintenance. If you have a maintenance activity scheduled, pretty safe to run this before maintenance. Now, once you have all your backups, you'd see them in the backup tabs, and if you ever want to restore, you'll see them color coded. So black one is basically your manual backup, and blue is your scheduled backups. So you can click on these, and again, remember these have tags as well to help you recognize. And once you do a restore, you would be able to see what was the delta or the diff of config between your current switch configuration and what was backed up by DCNM at a switch level. So again, you can preview that, and if things look okay, you can do a restore. So that's how network backup and restore works. Now, DCNM also keeps track of your state and anything you've defined from DCNM in the resource manager. And again, this works not only for greenfield, but for brownfield as well. So if you're importing your fabric, your state would be imported onto the resource manager. Now here you'd be able to see your VNIs, both layer 2 and layer 3, your VLANs, networks and VRFs, your switches, your IP addresses, etc. Right? So everything literally you've imported and provisioned, you would be able to see the state here. And again, the reason why we keep track of the state is so as to allow a backup of not just the config, but the state. If you, for example, configure the same IP address in the fabric, it'll point you and it'll tell you that, look, you can't do that because this IP is configured and so interface, and also allows you with brownfield. So there's a lot of advantage of actually storing and learning the state in the resource manager. Now, endpoint locator, this is basically an application that's running on DCNM to keep track of your endpoints. And this is specifically for our VXLAN fabrics, both for easy fabric as well as external fabrics. So once you enable EPL, you'd be able to see a list of all active endpoints, both V4 and V6, as well as dual stacked endpoints. And you see what VRFs and networks these are active on, and a complete history of these endpoints over 6 months. You'll see recent notifications, and if any of your endpoints have, say, duplicate IPs or they're moving, you'll see all of those notifications right here. And of course, you get details of the endpoint, including the IP, the MAC, again, which leaf it's attached to, what interface, and lots more. Now, in fabrics, endpoints moving is pretty common. And if you want to track how these endpoints have actually moved and which leaf to which leaf over time, you can track that as well. Again, this is all historical activity for your endpoints. If you click on any of these charts, you'll also be able to see a trend of endpoints and your networks and VRFs over time. And by clicking on any of these charts, again, that takes you to a snapshot. You can generate diffs between time T1 and T2 and see exactly what was the difference in that particular data set. So this and more, this includes your endpoint activity as part of endpoint locator feature on DCNM. So Virtual Machine Manager or VMM allows us to get that compute visibility as part of the network topology view. If you remember, in the same view, we can now get compute if you click on it. So here you begin with integrating with your vCenter, and DCNM would get a read-only access and get all the repository from your vCenter. So if you click on all, you get details including all your VMs, and these are color coded, which means that red indicates whether the VMs are even turned off or on, and how these VMs are mapped up to your vSwitches or distributed vSwitches, how these vSwitches are connected up to your physical hosts, and how the hosts are connected to your leaves in the VXLAN fabric. So now getting that compute visibility in the same network view is possible with Virtual Machine Manager, and seeing what kind of VNICs and port groups you're mapped with, and if there were any misconfigs, this would be a good place to get started for us networking guys. Now the next one is Kubernetes cluster visualization, and this is a preview that we've added as part of DCNM 11.3. Again, like Virtual Machine Manager, you would integrate with your Kubernetes cluster, and on the right now you see an option for your containers, which you would click and get details of your namespaces or namespaces and pods, and you can click on your pods to get detailed information about that pod. Also download a list of all your containers in your infrastructure. So again, very useful to get that container visibility. Now, OAM has been part of NXOS for a long time, and running these between the switches and actually going into the CLI is pretty cumbersome. So we have integration of VXLAN OAM from DCNM, again shipping for a while now, and you can go into the topology view, and if you remember, there was quick search. You click right there and get your VXLAN OAM from there, which allows you to run your OAM between switches or between hosts. Now, if you'd like to generate simulated traffic within the VXLAN tunnel and see what was the path that was taken by that particular flow, you can see that for debugging purposes using OAM. So you need to give details including the IP, port, protocol, and VREF, and you'll see in blue the dotted lines which indicate what was the path that was chosen. Since it's in equal cost multipath, you'd be able to see the path, the spine that the flow traverses for that particular tuple information you just entered.
This one virus is killing your business, and that virus is customer referrals. Why? Because of these three reasons. First, you can't keep a check on it. Your business will.
You can also see detailed information including the ingress and egress interface, the discards, errors, the packet rate and byte rate, multicast, broadcast. You can see all these details in the detailed view, and again very useful for data plane debugging. Now, DCNM allows you to upgrade or install patches or RPMs directly from the controller. But for that, for the very first thing you'd need to do is put that image or patch or RPM into the repository, which you do by clicking on plus.
Once you have that in the repository, few steps there where you have to select the devices, specify what package, for example, you need to install, and select the switches where you'd like to install these, and pretty much finish the installation.
With switch upgrades, there are a few more workflows where it runs a compatibility check. You're able to also schedule the job based on the groups or a particular switch. So there's a lot more options that you'd see in switch upgrades. Switch maintenance mode is, again, you right click on the switch and you go into the modes and you'd see an option for maintenance mode. Now this is like GIR on NXOS, where you can basically gracefully shut down the interfaces and protocols and take the switch out of the fabric. Thereby no traffic is actually going to traverse that switch. And if you want to debug something, you can do that easily by putting the switch in maintenance mode. Or if you want to just completely replace the switch, this serves as a prerequisite as well. So you put it in maintenance mode and then you click on provision RMA. By this time, the expectation is that you would have your new switch all powered and cabled up the same way. You can manually find the new switch, or we fully support POAP as well. So here I have bootstrapped the new switch. You see exactly the switch shows up. If the model number looks okay to you, you click on it and do a swap switch, where DCNM will then copy all the configurations from your old switch to the new switch, and once copied, you can put your new switch in active or operational mode. So again, few clicks and you're going about with RMA, very easy operation using DCNM. Now DCNM also integrates with ServiceNow. So you see a DCNM application in your ServiceNow app store. Once you get about with the application, you can import your DCNM instance. And once you have imported it using the IP address, your mid server, and the credentials, in ServiceNow, you would be able to see the repository of your switches of the fabrics that are being managed or monitored by DCNM. So here you can see what kind of switches you have, what are the roles of these switches, what is the port utilization or availability in each switch, so detailed information on the repository. Now, if you would choose, you can also have the ServiceNow instance of DCNM auto create incidents based on any alarms that are generated in the controller for your switches in the fabrics. So if you choose to do so, DCNM would stream out all the critical alarms and you would see incidents being created for each of these alarms, which you can then go to assign, update, or resolve the case based on any updates to that particular incident. So that's the DCNM integration that we've added with ServiceNow. With DCNM 11, we introduced an application hosting framework, and pretty much these applications we talked about, like endpoint locator, config compliance, and virtual machine manager, these are actually plugins that are running on top of this framework. It's basically allowing us to host microservices in a containerized environment and build out a scale out model. Now, today this is open for Cisco applications, but of course we do plan to expand this to third-party applications as well. Now, the latest addition to this application framework is a Network Insights applications. We call them NIR and NIA, Network Insights Resources and Network Insights Advisor. So you need to host these applications on top of DCNM and a cluster of compute nodes. And basically, these applications are very powerful when it comes to day to operations, which is why you see these apps in this section. So these applications gather a lot of data and process and correlate all of it to give you visibility into your fabrics. Now, Network Insights Advisor is basically going to give us very relatable vulnerability information and tell us what kind of Cisco bugs or precerts or notices or hardening violations I have in my switches, and generate advisories based on the data it saw to even tell me how I can resolve these issues. Network Insights Resources, on the other hand, is focused on troubleshooting and debugging use cases. It is designed to gather and ingest a lot of telemetry data, both from the control plane as well as the hardware, ingest, correlate, and process that to give us a very detailed view on our switches and give us a historical view of what kind of resources are being used, trend them and baseline their behavior, and really generate anomalies on any violations of thresholds or latency being crossed for a flow, end-to-end flow path, drops, drop reasons, telling me, if my interface has CRC errors or is dropping packets, if there's any issue at a control plane level with my routing protocols. So there's a lot of view we get there in the Network Insights Resources application. So if you do have DCNM or do plan to use DCNM, I'd highly encourage you to check out Network Insights Advisor and Resources on cisco.com. Now,
Backtracking is a method of arriving on various solutions to a problem using brute force, like solving crossword puzzles or playing Sudoku.
Now, these are some reference slides on how NIR and NIA can help us with our D2 ops. I'm not covering this because this is a short session to actually go into all these details of network insights, but we do have other breakout sessions to actually cover network insights in detail. Now, some of the workflows we looked at in this session are all UI. So we looked at UI snapshots, but we have REST APIs which actually have 1:1 parity with the GUI. You can access these APIs looking, if you see at the bottom, we have this URL. So your DCNM IP/API docs is where you can find Swagger style APIs. And you can use these APIs to automate any operation or deploy anything at bulk or interface with third-party tools. Now with that, we also have the REST API tool, which you can click, and once you click that, you would see another window that would pop up. And for any operation that you would run on the GUI, it will show you what kind of API calls were made from DCNM. So that is basically very useful if you want to understand the API structure and architecture. Now, again, everything we covered about in this session was about provisioning our switches and our fabrics and how do we go about that. However, I'd like to just call out that if you don't want to manage your switches from DCNM but use DCNM to monitor your switches, you now have that option as well. So you would create your fabric using the external fabric template and you would mark that fabric is monitor mode. So enable only monitor mode. Thereafter, DCNM is not going to push any configs to your switches in that fabric. However, you can still use DCNM for any events, alarms, monitoring data, environmental data, looking at your real-time network as well as compute visibility, looking at your containers, how your endpoints have moved around, or looking at the history of your endpoints using EPL or use the network insights applications. So you have that option without managing the switches, and all the configurations that are needed in order to use these applications would be generated by DCNM, and you go about use your own mechanism to provision your switches. But you do have that option now with DCNM 11.3. Alright, so in this section, we're going to look at a demo. I have recorded the demo in order to walk us through some scenarios that we have discussed in this session. So let me show you the topology that we're working on in this demo. So site number 1 is going to be a greenfield site where we have a leaf, spine, border gateway. Site number 2 is going to be a brownfield site with again 2 leaf switches, 1 spine, 1 border gateway. So that way we will cover creating the fabrics using our easy fabric templates. We'll cover greenfield and brownfield. We'll import the switches and we will deploy not just the underlay for these sites, but also we are going to then create the DCI router. We will interconnect these using multi-site and extend layer 2, layer 3 using multi-site. And thereby we're going to look at the networks and VRFs workflow in order to provision overlays as well. So that is what is going to be seen in the demo in this particular section. Alright, so as we've seen in the topology view, we have 2 fabrics and we're going to do greenfield in one, brownfield in the other, and we'll interconnect them using a core router, and we'll use VXLAN multi-site in order to do so. So here I have a recorded demo simply because we don't have the leeway to use too much time since this is only a 90-minute session. So I've recorded this demo to take us through the entire process. So let me play this and let's go through the UI. Now from the UI, we go into Control and Fabric Builder. That's where we begin. And since there are no fabrics here, you see the screen is pretty blank. And we're going to click on Create Fabric. Now as we click on Create Fabric, the first thing we want to do is select the template and give it a fabric name. Now since this is all VXLAN, I'm using the Easy Fabric template. And we'll begin with site 2, which is going to be a brownfield site. So basically this is already created. I'm simply importing the switches in order to incrementally manage them from DCNM. However, I want to make sure that all the configurations are preserved. So here I'm going to start with giving it an AS number. This is the same AS number that I had in my fabric. Now rest of the options, of course, these can be changed, customized. The resources, as we see, these are pre-populated, but I am going to change them based on, again, what I'm using in my fabric currently. So I'm changing all of these to 20.x. So let's change that. And we're going to go into another VRIF light subnet IP range there, and we're changing that as well. And of course, all these other fields can be customized. The other thing I'm going to do is create a backup schedule for my fabric, since I want to back up any and every change, and I'm doing this every hour and once a day. So now I'm going to save my changes. I saved my fabric, which means that my fabric will now be created. So, all right, so here we go. Now my fabric is there. It's called site 2, and I'm going to add switches there. Again, I'm going to use the seed switch IP address, which is 198.18.4.201, and I'm giving the credentials for the switch right there. I'm giving number of hops as 2. Another point to note is preserve config is set to yes because this is brownfield. Now the switches, 2 hops from the seed switch are all recognized, and I'm going to import them into the fabric. So let's wait for this to be done. It's importing all the switches one by one. Alright, I'm just going to speed through this process since this may take a little bit of time right there. Okay, awesome. So we have the switches in the fabric. So I'm going to close this bar. And the next thing we want to do is select the roles. Now by default in DCNM, all of these are leaves. So I have a border gateway here, so I'm just going to select that. And then the other one is a spine switch, so I'm going to set the role to spine. Whereas the other 2 leaves are leaves, so I'm just going to leave it as is. And as you see, it's hierarchically organized. And in the tabular view, it gives me details of all these switches, what is the serial, model number, and a lot of other things right there. So I define my intent for the fabric and the switches, preserved config, and I'm doing a save and deploy. Now, as you see, since this is brownfield, you're seeing a migration mode tab over there, which means that DCNM is not only going to push configs, but first thing it's going to learn the configuration and the state, and then it will check if that's per best practice. And then any changes that you wanted to provision in step 1 and 2, when you created your fabric and you added your switches, all that intent, the configurations for that intent would be generated. So that's what's really happening at this point. So this may take a little while, especially when it's brownfield. So again, I'm going to speed through this process since this may take a few minutes. All right, and we see there's configurations generated, especially for the leaf switches. Now that's all the config that will be pushed to the switch. And you see there's a side-by-side comparison between the running and the expected config. All the ones in green would be pushed out. So that looks okay to me, and I'm going to deploy the configuration. And so we really went through the intent, save, preview, and deploy. Those are the steps that we followed in order to first create the fabric, import the switches, and push any configurations right there, including the backup schedule, which was done at a fabric level. So I see my leaf switches are pretty much done here, and we see there's a progress bar over there. So it's all 100%, and these are all green, which means that the configurations are exactly per the intent. Now I'm just going to pause here and quickly say what we're going to do here. Now here we are going to add a site 1, which is going to be a greenfield site, and we'll follow the process and we'll see what are the differences between greenfield and brownfield. So again, I picked from the easy fabric template, giving it a name which is site 1, and this is my AS number 65001. Now again, rest of the fields are all configurable. I'm going straight into the resources. That's looking okay. The one thing that I'm going to change here is by default, DCNM is going to reload the switches when it's green field. Now, if you don't want that reload, you can actually, click on enable or disable from here. So the cleanup will happen without a reload, and that is when the preserve configuration of the switches is set to no. So we don't want that, so I'm just going to simply enable that. And in the cleanup option, basically DCNM leaves everything on the switch, including the management IP and the default route, of course, but everything else is wiped off, followed by reload, which you can ignore using this option. Again, I'm going to configuration backup and creating a backup schedule for my fabric and clicking on save, which is going to create my fabric, which is called site 1. Next step, adding switches. Now I could do POAP here as well, but I'm going to discover them using the seed IP, the number of hops, and DCNM basically is going to use CDP and SSH to discover all the switches from the seed switch. Now I see preserve config is set to no because this is green field. So in this fabric I have 3 switches, all manageable, and it's warning me that the configurations will be removed, which is okay. And since this is green field, I'm okay with wiping off the fabric and the switches. So here we see again it takes a little few seconds, so I'm just going to rush through that. Alright, so that just created my site 1 and site 2 as we see there. Now the next step is I have my fabrics and I'm going to go into the interfaces tab, and for a particular interface in the leaf switch, since it's host facing, I want to set it to access port. By default, all the interfaces, as we know, are set to trunk. So I'm searching for interface 1/2 on leaf 1, and that's where we see the result. So I'm going to click on edit. And again, as we see, it's trunk port, but we're changing it to access. And I'm quickly going to pause here to show you that this is basically a policy or a template that was already existing in DCNM. So I'm just picking that, and as you see, all the fields are populated, and these fields exactly per what is defined in the policy template. So this is, of course, amongst many other templates that are shipped out of box. You can customize these, you can create your own, so that way it makes the solution very, very flexible. So here I'm going to leave everything at default, save my intent, and preview the configurations just to make sure the config is right. So it's making it an access port, and you can also check the current config and do a deploy. So basically here is where I changed the mode of an interface from trunk to access using a policy. So here it's just deploying the interface config. So we'll just give it a couple seconds and that's done. Now we go into control fabric builder, and the next step would be to import that core router, basically what's going to be used for DCI. This time I'm going to use an external fabric template, and I'm going to give it a fabric name, core 1, give it an AS number, and this is what, if you remember, we discussed, if you want your fabrics to be in monitor mode, this is the template to use and check this option. However, in my case, I don't want to have it in monitor mode. I'd like to manage it, so I'm saving it. So this is going to go fairly quick because I just have one switch here, which is my core router. So I'm going to discover the switch using the IP address, and then the username, and then the password and number of hops. Of course, you can change that, but just to go quick, I left it at default. And I'm importing the DCI router into the fabric. So that was the only switch I was interested in order to have my DCI connections. I needed a core router there. So that's what I discovered, and I'm importing into the fabric. So again, this is taking a couple seconds, so I'm going to rush through this, and there we see it is the DCI router, and you see that it's gray. So every time you discover and import a switch into a fabric, it's going to show gray because you haven't pushed any config. When you start managing it, when you do a save and deploy, that's when you're going to see the colors change. So here I'm defining it as a core router, and I'm doing a save and deploy. And again, it already has all the configs. I've already done it using CLI. So the config here will be, just I think 3 or 4 lines to create that BGP instance right there. Yeah, there we go. So you see it's out of sync because it doesn't have these configurations, right? So that's configuration compliance kicking in and telling us that it's out of. So this configuration will be deployed onto the core, and then you're going to see that the color is now green, which means that it's exactly per the intent. Now I go back and I'm going to see 3 fabrics right here. This is exactly what I wanted. Now we're going to do multi-site. So step 1 for multi-site is to create an MSD, which is a fabric of fabrics. So I'm just going to use the fabric template, which is my MSD fabric. Give it a fabric name, which is MSD1. And again, you see these are all the parameters that are defined in the template. In DCI, for my deployment method for multi-site, I'm using the centralized route server option. I'm giving it a route server list with the BGP AS number, which is the same as my core, and setting the auto deployment flag for my underlay fabric connections. So here I've defined my MSD parameters, and again this is just like creating a fabric, except that it doesn't have switches, but it's going to have fabrics. So we're going to click on move fabrics, clicking on site 1, and one by one we'll add 3 of them. So we just added site number 1. All right. Now let's go about adding site number 2, which is a brownfield site. You see the fabric state is standalone, which will change because you're moving it to an MSD. So site 2 is added. And then the next one, we are going to add the core. So that was another fabric, and I'm adding that fabric into my MSD.